All right, so for this problem here, we have calc air buys a new passenger plane for 538 seats. For the first flight of the new plane, all 538 tickets are sold. Assume that the probability of an individual passenger turns up to the airport in time to take their flight is 0.91. We want to model this distribution of random variable t as the number of passengers that arrive on time to take their seats. Well, we know that there's each of these seats, the passenger comes or they don't come. So there's a success or failure. There's 538 successes, and the assumption we're making is that each passenger is independent of each other. So what I can say is that t is a binomial distribution with n is 538 and the p is 0.91. And we are going to assume that all passengers are independent, which in airlines is not a correct assumption, but we're going to make that assumption anyway. So now we want to find the probability that t equals, right, the probability that t equals 538. Well, if I go to my calculator, I know it's binomial now, and so I can just go distribution. I want binomial PDF because I want exactly 538. There's 538 trials. My probability of success, meaning they arrive on time, is 0.91, and there's 538 is my x. And when I do that, I get approximately 0. Okay? And what this means is that the probability that all the passengers will arrive, exactly all the passengers will arrive on time is basically 0%. So the plane is not going to be filled, is what this means. Okay, C part. Now it says find the probability that t is bigger than or equal to 510. Well, my TI-84 doesn't do it directly like this, so I have to outthink it, because I know CDF always goes from 0 up to a value. So this is the same as saying 1 minus the probability that t is less than or equal to 509 passengers. So if I do that probability, I'm going to go 1 minus the probability that I'm going to go binomial CDF, and I'm going to go, again, there's 538 trials. My probability is 0.91, and I'm going to do it 509. And so now my probability is a lot better. So I get 0.000672. So what this result means is that there's going to be at least 510 people on the plane. That's a probability very close to 0 as well. And so it is highly unlikely that the plane will be filled. And it's likely that there will be empty seats. Okay, because if this is true, I'm gonna have empty seats, is what this says. If I sell exactly 538, or if I sell only 538 tickets. Okay, so now if I know that though, and I go to D part, it says calc air knows that it's highly likely that there will be some empty seats, which we just figured out. So it's going to sell more tickets than seats. And this is done all the time by airlines, that they sell more tickets than seats. Because you sometimes hear in the airport that, oh, we've overbooked today. Can people come and get a voucher for giving up their seat? So find the smallest possible number of tickets sold that when this probability is at least 0.1. So I want the probability that, and I'm going to introduce a new random variable now. So let me call it n. I'm going to say n is a random variable that's binomial. Well, I don't know what n is. N stands for new, but it's still a probability of 91%. And so I really want to know when is the probability that n is bigger than 510. That probability, when this is true, I want it to be bigger than or equal to 0.1. Again, my calculator doesn't do that, so I can go 1 minus the probability that n is less than or equal to 509 is bigger than or equal to 0.1. If I do some algebra here, I subtract the 1 and divide by the negative, I can say the probability n is less than or equal to 509 is less than or equal to 0.9, because when I divide by the negative, I have to switch the sign. And so I am looking for the n value for this to be true. So when I go to my calculator, it's a little trickier to do this one. I'm going to go to my y equals, and I'm going to do binomial in my calculator, binomial CDF. But my trials is what I don't know. That's my x. I know that this is 0.91, and my x value is 509. I'm going up to, and I'm going to go plug that into here. Remember, I'm looking for n, and so these are discrete values. So I'm going to go to my table set, and I know that 538 is not enough, but I'll start there, and I'm going to go by ones because I know they have to be integers. And I'm going to, from here, go to my table and start to look at the probability values. And as I go down, I want the y1s to be less than 0.9. And here it is, 551. I can see now, therefore, n is equal to 551. So the airline is going to sell 551 tickets. Even though there's 538 seats, they are going to sell more tickets because they know that people won't show up to make the flight, and so they want to fill all the seats up. And so this is how many tickets they will sell. E part says how many tickets could Calc Air sell, so the expected number of passengers turning up on time is as close to this as possible. Well, so my expected value for binomial is n times p, and I want it to equal to 538. So if I go n, p is 0.91, it's 538, and then will be, if I put this in my calculator, 538 divided by 0.91. I know that they will sell 591 seats. Okay, this is the expected value. If they sell 591 seats, this is what they expect to fill up exactly, no empty seats. And finally, when we look at F part, for this number, the 591, find t at 538 and t at bigger than 538. So I want to find the probability that t is equal to 538 and the probability that t is bigger than 538. So this first one here, I'm going to go to my calculator, binomial PDF, and I'm going to have 591 trials. My probability is 0.91, and my x value is 538, and I get 0.0573. So there's a 6% chance that it'll exactly equal to 538. And if I do also more than 538, if I go, in order to do this one, I'm going to actually, it means, make sure I don't want equal to, just checking that. So that's going to be 1 minus the probability that t is bigger than or equal to 538. So when I do that, it's going 1 minus distributions, binomial CDF, and it's 591. My probability is 91, and my x value is again 538. And so now I get 0.468. So this says there is about a 6% chance that there will be exactly 538 people show up if I sell 591 tickets. But I also, this here says it's only there's a 47% chance that more people will show up than what you have space for. So the more than 538 people will show up. And this is when your airline goes on the announcements and says, oh, we have overbooked our flights. If you would like a voucher and can fly at a later time, please come now. Because they do this all the time. I hope that helps clarify this problem.